Hello, this is question 13 on your AS level maths paper from June 2022 from Edexcel. You have to show this trigonometric identity. Yeah, so can work, when you have a trigonometric identity, we are not moving things from one place to another or multiplying by the denominator or something like that. We are working with one side or the other. So I'm going to try with this side, and you know that sometimes it's not immediate to get them. So if something seems that is not working, you can start again with another strategy and maybe that works. Yeah, so don't despair if it doesn't work. So I'm going to put this together. So I'm going to multiply, well, actually tan is sine divided by cos. So I can do 1 over cos plus sine over cos is going to be 1 plus sine over cos. Yeah, so just thinking that tan is sine. I'm not going to skip steps. So let me sine divided by cos, and this is the same as 1 plus sine divided by cos. I need to have 1 minus sine in the denominator. So it's going to be difficult to convert this cos in 1 minus sine. So I can think what happens if I multiply 1 minus sine here in the denominator and in the numerator. Yeah, if I do that, I will have the denominator that I want here, and I will have difference of two squares. So that's what I'm going to do. I'm going to multiply 1 minus sine on the top, 1 minus sine on the bottom. So in the numerator, these two things is difference of two squares. So it's going to be 1 minus sine squared. And in the denominator, I have cos 1 minus sine. I know 1 minus sine squared is cos squared. And now we are going to have it very quickly. So cos theta 1 minus sine. I can cancel the square with this one, and then I have cos theta divided by 1 minus sine. That's what I wanted to find. Yeah. So this is the first one. Then, given that cos 2x is different than 0, solve for x between 0 and 90 this equation. They don't say hence, but this part here looks like this part here. So my first inclination would be substitute this by this. Yeah, I think it will help. So I would do always that. If you have found an identity in the first part of a trigonometric question, and then you have to solve an equation that has that identity, I always would try to use it. Sometimes they say hence, which helps you to realize. If they don't, still I would use it. So I know this part, comparing with this expression here, I know it's going to be cos of 2x divided by 1 minus sine 2x. So I'm going to substitute that by cos 2x divided by 1 minus sine 2x. And then this is going to be equal to 3 cos 2x. So this is the equation that I have to solve. Yeah. I can, for example, multiply to get rid out of the denominator by 1 minus sine 2x. So I have this 3 cos 2x times 1 minus sine 2x. It says cos 2x is different at 0, which means I can divide by cos 2x in both sides. And then I have that 1 is 3 minus 3 sine 2x, which means that sine 2x is going to be minus 2 divided by minus 3, which is 2/3. Yeah? And now, remember, every time I have 2x here, or I have number multiplying the angle, I'm going to change my interval. So this interval is for x. I'm going to rewrite my interval for 2x. So I'm going to multiply everything by 2. So my interval is between 0 and 180. I'm going to find my solutions in this new interval. 180, because if I don't do that, I will miss solutions. So I go and put sine minus 1 of 2/3 in the calculator, and I get that 2x can be 41.8 to 1 decimal place. This is the first solution. Second solution, to have the same sign, will be 180 minus that value. So the second solution will be 138.2 to 1 decimal place. But this is the value of 2x. I want the value of x. So I'm going to divide by 2. So x is going to be 20.9 degrees and 69.1 degrees. Yeah. If you don't remember well how to solve this type of equations, there is another video that I explain how to solve this type of equations in general, not with one particular exam question. Yeah, and that's all that we have to do for this question. I round to 1 decimal place because that's what they say. If not, you can round to 1 or 2 decimal places, and that's fine. Yeah, that's it.